In the polynomials chapter, we looked at all different types of polynomials with all different exponents. In this chapter, we look at a very specific type of polynomial called a quadratic. And there are a couple of fun facts about quadratics. The first is that it's nonlinear. It's written in the form y equals ax squared plus bx plus c. That was a specific type of polynomial called a trinomial that we looked at in chapter 7. So the quadratics that we look at in this chapter should look a little familiar. It has a shape of a U. If you look down below in example 1, you can see what the picture will look like. And that U-shaped graph is called a parabola. The lowest point or the highest point, you'll see different examples of the parabola, is called a vertex, which is a word that you already know. And then there's a line that goes through the middle of the parabola, which we'll look at in a moment, and it goes right down the vertex, and it's called the axis of symmetry. So let's look down at example 1 and let's identify all of these things that I just mentioned. So we've got our U-shaped graph, right? Looks like a parabola. It's got a vertex down here. That's the lowest point. And down this vertex, right down the middle, what you would call in 6th grade the line of symmetry, we now call the axis of symmetry, and that's where the parabola kind of splits in half. So let's just identify the points. So the vertex is right down here. So we just write the coordinates. That's 2, -3. Then we've got the axis of symmetry. Now that's an imaginary line. I'm going to draw it dotted because it's not a real line, but it's an imaginary line going through the vertex, kind of splitting it in half. And the equation for that is x equals 2. Now remember, vertical lines are x equals lines, and so it goes to the point 2, so it's x equals 2. The domain is the set of all values of x, and there's no restriction to what you can plug into x. You can plug in any point on the x-axis. It will always be on the graph. So the domain is all real numbers. Remember that symbol. The range, however, is not all real numbers because there's nothing below this vertex point. So the range stops at -3. So the range is y is greater than or equal to -3 because I could be -3 or above -3. Increasing and decreasing you don't really see very often, and it's more of just a thing where you recognize when the graph is going upward and when the graph is going downward. So this graph's values are increasing on the right side of this vertex point. The graph is going upward. So what we do is we would say it's increasing as long as x is greater than or equal to 2. And it would be decreasing, meaning if you go from left to right, even though the arrow tip is there, if you go from left to right, the graph is going downward. And so be decreasing at x is less than or equal to 2. All right, now let's actually graph some of these. So we're going to be creating our own parabolas. As we go through this chapter, we're going to make the graphing more and more complex. Right now, the graphing is going to be at the most basic level where it's just a simple monomial, right? We know this language, simple 2x squared, right? We're not going to add all that other junk on. We're just going to keep it nice and simple. So you go through and you just, do your calculations like normal. Remember, follow order of operations. 2 times -2 squared is 2 times 4, so that's 8. So why don't you fill in the chart on your own? Press play when you're ready. Okay, so let's graph these points, -2, 8. -1, 2, 0, 0, 1, 2, and 2, 8. So you should get a U-shaped graph. If you don't, then something's wrong. And then you're not playing connect the dots. You're not connecting them with line segments. You're making a nice smooth curve. Don't forget to extend it, put arrow tips on top, And there is my graph of g of x equals 2x squared. Now it also wants us to graph f of x equals x squared. Now that's something that we called in another chapter a parent function. That's the most basic parabola. So we're going to compare everything to y equals x squared. It's kind of like the line y equals x, a simple line, goes through the origin, doesn't have any y-intercept or zero-intercept, is one slope. Anyway, similar to y equals x squared. So let's fill in our chart. So this is just simply negative 2 squared. So we got 4, 1, 0, 1, and 4. So let's graph those. So there's f of x equals x squared. And what you should notice is that the 2x squared graph is much skinnier. They have the same vertex, but 2x squared got more narrow. So let's write g of x is narrower than f of x. Okay, let's do another one. Now we've got the graph h of x equals negative 1/2 x squared. So a little more complicated with the order of operations, but nothing that we can't handle. Negative 1/2 times negative 2 squared is negative 1/2 times 4. So that is negative 2. Why don't you pause the video and see if you can fill in the rest of the table on your own. All right, there's my table. Now let's graph. Negative 2, negative 2. Negative 1, negative 1/2. 0, 0. 1, negative 1/2. And 2, negative 2. So extend it and just kind of, imagine where you think the parabola is going to go. It's going to kind of look like that. So that's h of x equals negative 1/2 x squared. They want us to compare it to y equals x squared. So just grab those points from the previous question. It goes through 0, 0, then it goes through 1, negative 1, 1, and then it goes through negative 2, 4. What you'll notice is that the graph is flipped down. It's also a tiny bit wider than f of x equals x squared. So let's write both of those things down. If you had to take a guess about why you think it got flipped down, what would you say? What do you think about h of x makes it flip in the other direction? All right. So we'll get to your guess in a moment, but here's some spoilers about why the graph was getting narrower and wider. So the basic parent one is where the coefficient is 1, y equals x squared. But if the a value, if that coefficient is greater than 1, then it gets a little skinnier. If the a value is a fraction, then it gets wider. Now, let's see if you were correct with your guess. The fact that it was negative was what made it flip down. So when the coefficient is negative, it flips. And then it also does the same thing. If it's a negative whole number or negative number greater than 1, then it gets skinnier and flipped down. And if it's a fraction that's negative, it gets wider and flipped down. So maybe you were thinking that that was why the graph was changing when we were graphing 2x squared and negative 1/2 x squared, but now you know for sure why it happened. If you have any questions, write them down and ask me when you come to class.